Hello, and welcome to Azure Functions Deep Dive session. This is the first session after lunch, the best time to actually fall asleep a little bit. So get relaxed. They're not serving popcorn here, so I will try to make it as boring as possible for you so that you can really take a good nap. My name is Vjekoslav Babic, or simply Vjeko. I've been an MVP for Microsoft Dynamics NAV for 7 years. I've been blogging for 10 years. I've been busy with NAV for more. And I've usually been the crazy guy here at TechDays presenting crazy stuff and tips and tricks that Microsoft hates. They're actually nodding at me from the first row. Yeah, that's. So this year, for a change, I'm not doing a black belt session. I'm not doing anything crazy. I'm actually just doing something interesting and easy. So what is this session going to be about? Well, obviously Azure Functions. That's what the title says. So what about Azure Functions? We'll talk about what they are. We'll talk about how to use them, and we'll talk about why we would want to do that. And this session will have some theory, of course. It will also have some practice, of course. So, what are Azure Functions? Well, if you ask Microsoft, they might not tell you exactly the first thing that comes to mind. Azure Functions are FaaS, or FaaS. This is yet another buzzword from the as a service collection. It stands for actually function as a service. So if you've never heard of what function as a service is, then maybe you've heard of this, serverless architecture. That's what Microsoft would tell you that Azure Functions are. And then you can ask, like, how can it be serverless architecture? What kind of sense does that make? Well, or also you could think like serverless architecture, it's something like, look, ma, no hands. I don't need a server. Of course you need a server. So what is serverless architecture? It is a concept in which you do not need to worry about server or about provisioning any specific hardware at all. It is, of course, cloud-based. It is fully event-driven. It is stateless. It is short-lived. And it requires, theoretically, zero administration. So what does this all mean? It means that, in what way is this actually different from other things that we know from this as a service stack? Like, why is this different than software as a service or platform as a service? First, this is not platform. Platform as a service gives you facilities that you need to utilize to actually make something work. Azure itself is platform as a service. Software as a service typically requires you to configure virtual machines, to configure big fat applications or things. Here, with functions as a service or serverless architectures, as you will see, you actually have very light, thin layer. Everything is running in containers. Nothing is running in virtual machines. Everything is really provisioned on demand. So resources are provisioned on demand. They are assigned on demand. It is very lightweight, fairly fast, as we will see. So this is a little bit about what serverless architecture is. Let's now talk a little bit about Azure Functions, and let's see what they are and what they allow us to do. So first thing that we could say about Azure Functions is that they allow you to choose any language you want to write them in. So actually not any language, but a lot of languages are out there for your disposal. You can use C#, you can use F# if you, for whatever reason, want to, or you can use Python, or you can use JavaScript or TypeScript or PowerShell. I know that Waldo would like to do that in PowerShell. So there is really a number of languages that you can choose. It doesn't care. Funny thing is, you can provision one application for function services and then have one function running in JavaScript, one in TypeScript, one in C# and one in Python. It's also completely legal because they are all completely detached. We will see how that works. Also, I would like to address this financial thing up front. It is actually very cheap to run. It's almost next to free. You have 1 million invocations per month, and then after that you pay something very little. So essentially for testing and for most typical use cases that we in NAV world may come up with, you will just perceive them as free. So they have this very affordable model. We can discuss it in detail if you want during Q&A part. Then we can also use dependencies. It means that when writing those functions, we do not necessarily need to contain all of our code in the same place. What we can do, for example, if we are in JavaScript, it's actually running on Node.js, so we can use npm to pull any dependency we want. Or if we are in C#, we can use NuGet to pull any dependency we want. We can even build our own dependencies, which is the nicest thing of all, especially for us in the NAV world, also something that we will see a little bit later. It comes with integrated security, which means that you can secure access to those functions. That's also something that we will address in a little bit more detail. So it supports OAuth authentication with a number of providers, and it also allows you to secure it using access tokens. Also, we have flexible deployment. Flexible development. We will see that we can use a number of options to write functions. We can actually do them in browser, or we can use a full-blown development environment, such as Visual Studio, for example. And finally, we have this open source platform that Azure Functions are, which means that they are completely open for anybody else to use, for you to contribute if you want. So here is the GitHub repository where Microsoft is actually maintaining the entire platform. So it's currently in development, it's constantly in development, it is being changed as we speak. One demo broke for me. I hope it will work later on, and I can only blame it on things being changed in Azure Functions platform. So let's see when we get to that point. I will give you an advanced warning about this demo. So yeah, I have to do some lame excuse before a failing demo. Anyway, this is a little bit about what Azure Functions are and how they actually work. How do we invoke Azure Functions? We have a number of ways, and they are actually not just intended for us to replace our NAV stuff. We have a number of Azure triggers that we can attach them to, so when something happens in Azure, your function can execute. Or we can use webhooks like GitHub hooks or generic hooks. If there is an application that publishes a webhook, you could attach Azure Functions to that hook to execute your own logic when some event somewhere happens. And also you have those other triggers, which are timer, and the most important one of all is HTTP request trigger. This is the one that we will spend actually the entire session today talking about. So plenty of different ways how we can invoke those functions and how we can make them run. Talking about their architecture, it is nothing complicated. We have applications, so all of the functions are hosted in applications, but those applications are not projects or source code applications the way that you are familiar with when you develop stuff. They are simply containers that combine some settings and security and authentication options. They simply contain your functions, but they do not, applications themselves do not have any code. So they are simply containers or placeholders where you will store your functions that simply simplify administration of all functions by applying specific settings that apply to multiple functions at once. And then once you have an Azure Function application, you can define multiple functions, as many as you want, within a single function application. So each function comes with its source code. It can have its own language. It has its own access keys. It can specify its own triggers, and it can have its own bindings, etc. So you can monitor it individually. Every single function is individual. You completely manage it as an individual entity. So this is a little bit about Azure Functions in theory. So let's take a look at the first demo. Let me stop talking and let me actually show you how those functions work. So I will go in my Azure virtual machine where I will be writing some code. And I will start by simply creating an Azure function application. I have a few, but I want to show it from the start so that you can see how easy it is to actually get started. So we'll just click New, and then in the list of things that I can create, I will select Serverless Function App. And here I will give it a name. I will say TechDays 2017. Oops, taken. What do you know? So NAV TechDays 2017. This is not taken. Then I will choose location. I will put it to West Europe. This is closest, I think, to us. And then I will select an existing storage group. This one is fine. and I will create this application. So once you click create, it will validate if everything is fine, and then within a couple of seconds, half a minute, you will have your application in there. You will be able to use its resources. Let's wait for those couple of seconds. I will click on function apps here, and maybe it's already there. Let's take a look. Not yet. I'll give it a little more time. Okay, it says deployment succeeded. Go to resource. And here I will be now in my Azure function. So it's complaining about NAV TechDays. It's saying something, whatever. So let me see if it's, yeah, it's listed here. That's fine. Good. Once I am in my Azure function application, I will click these functions and then this plus right next to it. So it will ask me what kind of function do I want to create. There are a couple of options. It selects this webhook plus API, which is in fact an HTTP trigger function. So I will select that. This will allow me to invoke it as if it was a web service. This is a primary thing that we would want to do from NAV anyway. And then it asks me for the language. I will go with C#, and I will just create this function. So at this moment, it creates the function and shows the source code to me. So it will be a piece of C# code that I will be able to start invoking immediately. So there it is. So this is my very simple C# function. It receives a parameter either through query string or through request body. And I can pass either of those. If you want to invoke it, you can click this get function URL. Then you simply copy this URL. I will try it immediately in my browser. I will put the function here, and then I will add name is TechDays. Enter, and it tells me hello TechDays. Okay, it returns some XML in a string. I don't know. I think it's just I think it's simply Chrome that shows it that way. If I open it in Explorer, I'm pretty sure I will not see this XML. I don't know. Why is that? No? I cannot even do that. Let me see. Ah, okay, it wants to open it. Yeah, it receives some JSON from there. Never mind. It works. So I've seen it here. Good. So that's how easy it is to actually create a function and invoke a function from the browser. But we are not invoking them from browser. We're invoking them from NAV. So let's actually go into our AL development environment, and then let's invoke this function. So I will start by creating a new code unit. So it will be code unit 50,102 my demo.al. Inside of here, I will do this code unit. I will invoke demo function, and then here I will paste my URL. So let's take the URL, copy. I'll paste it here and add name is Vjeko. Okay. I save that. So this is 50,102, my Azure function demo. I have prepared a page extension for my order processor role center. I will simply invoke this code unit from here, my Azure function demo. Let's make sure everything is in place. On run, we'll invoke this. It will show the result in the message. So yeah, I feel confident it will work. So let's take a look. So I'm deploying this, signing in, and then I have this invoke Azure, click, hello Vjeko, what do you know? It's that easy, in fact. So, good, job done. Questions and answers. No. I have 2 more slides to show. Okay. So, that was how easy it is to actually get started. It takes all 15 seconds plus some popcorn time until it actually deploys all the resources. So how do we develop those functions? Obviously, we can use web browser, go into Internet Explorer or Chrome, and then just write some code in there, and you probably do not like that, me neither. So you would not use web browser to actually write functions. Visual Studio Code is an amazingly popular platform and actually very, very nice platform. It also has support for Azure Functions, but it's very weak. So I would also give it one big fat no mark over it, because you cannot just do everything from Visual Studio Code. You can do some things, but not all. Not yet, at least. I'm pretty sure it will be possible. There are other environments that you can use to work with Azure Functions. I don't know, if you develop for Python, you could use some environment other than Visual Studio Code, or if you develop for Java, or if you develop for F#, you probably use Visual Studio, but what do I know? So there are those other development environments that certainly will work, but what I will actually spend most time today is Visual Studio. So we will do some Visual Studio development where we will see how nicely Visual Studio integrates with Azure. Not just Azure, but actually specifically Azure platforms. Visual Studio Code comes with Azure development workloads. It allows you to easily create Azure projects of different kinds, and we will see how nicely in the latest release of 2017 it actually allows you to develop and manage Azure Functions. So how does this Visual Studio development workflow look? You start by creating a function app project. So that's the holder of your functions. There is a template for that. You don't need to install anything specifically. When you install Visual Studio 2017, if you tick off this Azure during setup, everything will be configured for you. So you create this Azure Function App project from a template. Then in that project, you create a function, which is an object, which is in fact just a file of extension CS. I'm not sure if you can actually do JavaScript or F# or other types from Visual Studio. I never tried, so I cannot say no, but I cannot say yes either. So C# is supported natively. I don't know about others. Then, when you do that, you typically test locally before you deploy. You can simulate Azure environment on your machine, and then when you do, you can easily connect to that. You can see if everything works. And then when you're ready, you publish that to some application that is available in Azure. So let's take a look at how we develop Azure Functions using Visual Studio, real Visual Studio. So I will go here in my Visual Studio, and I will start with a new project. So the project type, I've selected this Visual C#, then Cloud, then Azure Functions. And then I will just call this Simple Demo. I will click OK. And I will wait a little bit until everything sets up. So it seems that everything is now set up. And I will right-click my project name, and then click Add, and then click New Item. Then Azure Function is automatically selected, so we'll keep it as is, and I will just call this function Hello there, not Hello World. I hate Hello World. So Add. Now it asks me a couple of options. What kind of function is this? What kind of trigger it should be? So we'll select HTTP trigger. Access rights, I will just say anonymous. We'll talk about security later. And then I will click OK. So this pretty much looks like what you've seen in the web browser, except that you have full IntelliSense support, access to all the libraries and everything from here. So it's much better to actually do it inside Visual Studio. Good. So that much for actually writing it. I will now run. I will press F5. And when I press F5, this will build and, oops. Oh, I didn't see this coming. This is a fresh machine that it was a clean machine, so apologize for this. This will take a little while. So while it takes a little while, let me actually see what's going to happen. Yeah, it's working fine. Good. So this is my local Azure simulator. This Azure simulator will bring up all the necessary infrastructures to simulate Azure as if you're invoking Azure. And here it tells me for all of my functions that I've exposed, it gives me this URL. So I will select this URL. I will copy it to clipboard. And then I will simply change the URL in my Visual Studio Code. So I will exchange this. with this. Good. So I will actually, let me do something else. Let me stop this, and then let me do just minor changes here to make it obvious that I'm actually working off my local machine, not from that application that we've seen. So hello, I will just put hi, and I will press F5. So it will now redeploy locally. My NAV is already deployed and it's waiting, so when my function is up and running, which is now, I can actually click this and I will see good. So that didn't work. Let's take a look at yeah. So you all like this error, right? Let's try to see what is happening with this. I will go back to my AL and I will copy this. Function is running and I will just try to invoke it from here to see if everything is fine. No, there is question mark. It's there. So it's not about question mark. Yeah. Look, well, one more demo down. So trust me, it would work. But but this wouldn't be that exciting anyway. Like, this is just to show that you can do that locally. This is a virtual machine, and I'll blame it on that. It does work. It is easy to actually do it this way, but you would eventually want to put it into Azure. So when you put it into Azure, when you actually deploy it, you will be able to invoke it directly from this Azure infrastructure. So let's actually do that. Let me stop this local simulator, which refuses to work for whatever reason. So there are no compile errors, it would not run. So I will simply just go and deploy that. So to deploy that to Azure, you right-click the project again, then you click Publish. And then it asks you if you want to create a new application or you want to select an existing application. I will use the same application that I have used previously, so I will just click Publish on existing application. It will connect to my Azure subscription, and then it will ask me, come on. Okay. Then it will load all of my function apps, and it will ask me which function app, actually all of my resource groups, and then in each resource group, it will allow me to select an application. So I'm deploying it to the same application that I've created earlier. This is to show that you can use the same Azure function application to deploy both from Visual Studio Code and to create new functions from web. It will not conflict out. Each function is individual. And the fact that you have this project for Azure Functions in Visual Studio does not mean that it has to be blank, fresh Azure application out there in Azure. So let me just select this and click OK. It will now create my publishing profile. Sometimes it takes a little while. So what does this publishing profile do? It connects to the Azure application, it reads its settings, and it prepares everything on my machine so that when I need to publish, it can just invoke a couple of services in Azure and push my source code there. There is going to be a difference between my function that I created in the browser and again, my function that I created in Visual Studio. Because when Visual Studio publishes the function, it doesn't publish the source code, it publishes binaries. So source code is available only on your machine, not in the Azure. So if you want to maintain and manage source code, you really have to do that inside of your web browser environment. So that's the only way where you can see the source code of Azure function in the browser. So let me actually demonstrate it. Let me click Publish. So when I publish this, it will not take too much time. And my function will appear inside of the list of my functions for this function application. So when I click my function application, and then functions. Okay, it still didn't refresh, so I will try to refresh. And if I click functions, I can see that I have hello there. And when I click hello there, I actually just see this JSON configuration, which allows me to configure the endpoints, but it doesn't actually show me the source code. As I said, the source code is not available in here. You can actually see all the files for this function if you click here and then you browse. However, you can see that there is just this JSON file, so you cannot access anything but that. If you go to storage directly into the storage account where this function is stored, you would be able to find the bin folder and everything that Azure infrastructure is actually storing, but you cannot access the source code. So I will copy the URL from here. Let's take a look if it's demo gods or it's my, yeah, now it works again. Oh, yeah, I didn't pass anything, so we'll just do name equals TechDays, and it returns hi TechDays. So I will just use that URL, put it back into my Visual Studio Code, save, compile, and with a little luck, it loads, sign in. Click Invoke Asier, and hi Vjeko, with all the differences that I've done in this specific project. So that's how easy it is, in fact, to develop functions using Visual Studio. So you do everything locally. When you're happy with the results, when you complete testing, you simply publish. Publishing will take like half a minute, and then you have your function up there in the Azure, ready to serve your requests. Good. Can we debug that? Well, if it's running locally in this local simulated environment, of course you can debug. That's why you have it. But can you debug it remotely? Yes, you can debug it remotely, and you can debug both the version that you have written in the browser, and you can debug the version that you have built using those binaries. So all of these options are possible. I will not demonstrate local debugging, but I will talk about how to actually do remote debugging. So when I say this demo is not going to be debugging my local Azure demo environment, it will actually be debugging Azure locally from my machine. So in fact, no, I will not be able to demonstrate this because my local machine does not want to load. Anyway, I will skip this part and let me talk about remote debugging. So imagine that my demo Azure worked on my virtual machine, which for some reason it does not want to do. So I would be able to hit the breakpoint and then run from NAV, it would stop there. But I will show that from remote. How do we configure remote debugging? There are two settings that you need to be careful about. The first setting is when you publish your function, you need to specify this debug. So if you want to start debugging, it's not enough to just use the debug configuration of your project. You actually have to specify that the publishing configuration is also debug. If you don't do that, you may not be able to debug. The second thing that you have to do is you have to switch off this enable just my code setting in the debugger of Visual Studio. So if you don't do that, again, you will not be able to debug. Depending on your configuration of Visual Studio may complain and not tell you exactly nothing about why it's failing. It gives you some obscure error messages, or it may give you an exact error message which tells you both of these things, like switch this debug configuration on and switch off this setting. But again, it depends on how your Azure tools are configured. This works in 2015 and 2017. And in 2017, it's at least polite and it tells you what is wrong when something is wrong. So I have configured this debugger option already. Let's take a look about how I can publish this for debugging. So here I can see that my configuration is release. So I will just click settings and I will change this to debug. I will save that and then I will publish my function again. So once my function is published and it's in debug mode, I can use Server Explorer to expand this Azure node and then App Service node, and then when it refreshes, I will see the list of all of my app services where I will have to find the application that I've created, which is NAV TechDays 2017. So I select that. And then this is actually resource. No, this is app service. This is the application. So I right-click the application and simply say attach debugger. And that's all. So this may fail, and I hope it fails so I can show you how to fix when it fails. So let's take a look. If it doesn't fail, let me just explain what you can do if it fails. This fails if your application is already set in debug configuration on Azure portal. And sometimes, for whatever reason, and again, this is probably because this is still being developed, it just doesn't catch this debug setting from there. And it tells you that debug setting must be switched, and it is switched. So what you need to do is simply go into that portal. You go into the application. So you select the application. Then you select function app settings. Sorry, I apologize. You select, just a second. Overview, application settings. And then here you select remote debugging on. You don't need to specify version of Visual Studio. It will be automatically specified by Visual Studio. So here I can see that my Visual Studio is running. So it is successfully attached to the process. Sometimes it would complain. It would tell you that it needs to be in debug mode. And it is in debug mode. So if that happens to you, you simply go here, switch debug to off. Save configuration. Go back to Visual Studio and reattach. And then Visual Studio will reconfigure everything and it will work. It didn't fail now, so I can just start debugging. So how do I debug? I simply set a breakpoint. So I will set a breakpoint in here. And then I will invoke, again, this function from NAV. I will click Invoke Asier, and you see that my Visual Studio is blinking. So obviously, I'm now debugging my Azure instance. I can step over. I can see that I have received this name from query string. It's Vjeko. You cannot change that. Remote debugger for Azure doesn't allow you to change the values in the watch window. So I'll just press F5. There is nothing going wrong in here and tells me, hi, Vjeko. So that's how easy it is to debug source code. Actually, how to debug functions when they're published to Azure. And this is why is this working? Well, you have published your binary. Your binary contains your debug information, and when you attach a debugger, it will match that debug information. It will know that this is the solution that you are debugging. It will know where exactly to stop. But what about the solution or the function that you actually wrote in the browser? So if you remember, I was in the browser, and I created this function called HTTP trigger C#1, which allows me to see all of this C# code. Can I debug that? Yes, you can debug that as well. So let's take a look at how we can debug that specific function. So I will just now detach my debugger, and then I will expand my function application, and then I will look at files. So when files refresh, I will see them grouped by function. I will expand my HTTP trigger C#1, and here I will see this run.csx. That's my source. So I will double-click that. Answer no when it asks you if you want to fix those line breaks. You do not want to fix those line breaks. If you do that, the debugger will not be able to attach because it will notice the difference between the source and debugged file. So just click no, accept it as is. And then you can set debugger breakpoint in here. And again, I will attach my debugger. And then I will just copy this URL again, so that I can paste it in my URL parameter in here. And let me go without this Vjeko. Okay? So I now do not have the necessary content inside of my AL code. So I will invoke it intentionally with a problem. Good. It runs. I will click Invoke Asier. And it stops. So I'm now debugging this web-created plain text code. So I will step over. String name will be blank, so it's null. It also doesn't read anything from my content, request content. It's also null. So here it will check if name is null, it will return this response, which is bad request, please pass a name on this query string, etc. So I can just go on and receive an error in here. So it tells me, please pass a name, whatever, blah, blah. So that's how you debug Azure Functions. Again, very simple. It's easy to configure, easy to start using. So good. What else shall we talk about? Okay, I've just demonstrated that. Thank you. Why do we need Azure Functions? So that's an important question. So serverless architectures and function as a service as a concept, and Azure Functions themselves are a very nice way to actually integrate different service workflows where things are happening distributed on multiple applications, on multiple platforms. You can easily connect them and have certain things happen, especially when you use webhooks or Azure events. This is something that, of course, we may want to do. We may want to attach them to a common data model, or we may want to attach them, I don't know, to anything that you can think of. But the more obvious example is to provide web APIs. If you think of how we developed software 15 years ago, if you were a vendor who was building some API, you would typically ship it as either an automation API or later as .NET API. These days, you would not probably ship it as .NET or anything, you would just ship it as a service API. So you would just make a service application that is invocable, that provides some REST endpoints that your customers can consume. So this is number one reason why you would want to also use Azure Functions. So they are very easy, as you have seen, to expose, to create some functionality in there, to make it possible to invoke your API, whatever that is. We will see a couple of examples of what that API can be just in a few minutes. So this is probably the number one reason why people would start using Azure Functions today. We in AL world, in NAV world, we have a more burning reason why we would want to start using something like Azure Functions, and this is replacing .NET interoperability. So let me just now try to wake you up a little bit. Let me see who has ever written a .NET interop library to be used with NAV. Okay, yeah, oof. Yeah, quite some of you. So now all of you who put your hands up, put it back up if you are happy with managing the deployment of those assemblies. Okay, I see 3 hands actually. 4 hands. Microsoft doesn't count, so we will talk about that. I want to know why you are happy. So there are a number of problems with those assemblies that you build yourself when you want to make them available. So, for example, the most obvious one is that if you change anything, it's a very breaking change for all of your CL code. So when you change your assembly, a good practice is to version up. And when you version up, then you break all of your CL. You have to recompile that. Actually, you have to re-reference everything. So if you're lucky, if it's easy, you will export your objects as text, then do a search replace all with a new version, then import, then compile. And again, if you're lucky, it will work. And it will be just 5 minutes exercise. If you're not lucky, if you're versioning up multiple things at the same time, it will be a longer process. So it's not that easy. But that's just the first part. First part is easy. You fix that versioning up. Now, if you want to make it available to your users, you need to deploy it on the server. If you're using direct deployment on server in the add-ins folder, you will first have to stop the service tier, then put your assembly there, then start the service tier. Also, you may want to use database deployment, which is kind of a simpler way. It doesn't require you to actually have physical access to the server. But then you have another problem. You have a problem with dependencies. If your assembly is using external dependencies, and those dependencies are used across multiple assemblies that you use, you will have a lot of problems. It is possible to solve, but not easy. And once you solve that problem, there is a big, huge wall that you just cannot come over. It's called Dynamics 365. Okay, we don't have extensions v1 anymore in Dynamics 365, but let's talk extensions in general. If you want to have your extension use your .NET assemblies, you just cannot make it work if you have dependencies across assemblies. It just doesn't work. You can have one dependency that is used from one assembly, but if you have the same dependency used from 2 or more assemblies, it just doesn't work. It will not allow you, it will allow you to build your extension, but it will not allow you to publish. And Microsoft's statement is, won't fix. And I understand they do not want to fix. Why? Because .NET Interop is going away. In extensions v2, there is no more .NET Interop. If we talk AL language, there is no more .NET Interop. So not only it is a very painful process to maintain our .NET assemblies, we now have a very burning reason why we would not want to use them anymore. That's just because AL language doesn't support them yet. And when I learned about this for the first time a year ago, that Microsoft is going to kill support for .NET in AL language, for me it was like the end of the world, literally. If you know me from earlier, you know that I've been talking about .NET in this way or another at Tech Days since the very first Tech Days. So I think I had like 6 sessions about .NET here and 2 workshops or 3. And for me it was, what? No .NET, what? And then Freddie told me, look, you don't need .NET. You actually need a solution for your problem. So .NET was a solution. Let's talk about another solution. Let's see why you need .NET, and then let's solve the root cause. So why do we need .NET? The question is, what is .NET good for? Why do we actually use that? We use that to do classes of things. Number one is to invoke web services. So if you want to invoke a web service, we need .NET. Then we do some string manipulations, then we do maybe some collections, whatever. There is a number of categories of tasks that we do with .NET that Microsoft has started replacing on AL language level with functionality that we can invoke directly without .NET, which actually is not just a replacement for .NET, it's actually implemented in the correct way. If you are a .NET guru or ninja, you know that .NET Interop actually uses reflection all over the place. And reflection is hundreds of times slower than direct access to same functionality. So when you're using .NET Interop, your .NET will not run as fast as it would run without, at least if you are invoking individual functions on .NET variable. If you embed everything in one single function in .NET, it will be good enough. But if you're invoking multiple things in a sequence, for example, you have a dictionary and then you feed 1,000 elements into that dictionary, it will be much slower than if you do it from C#, just because it's using reflection. What Microsoft did is they provided a number of wrappers for us that we can just start calling now from AL, things like HTTP client that I've used here in this example today, or JSON, or XML, or many other things. So all of these wrappers are non-reflection based. They are real things, so they are fast. So we have now received from Microsoft very good replacement for a lot of .NET, but not for everything. And for those other things that we still cannot solve with AL language, well, we have Azure Functions. And that's why they are interesting to us. Because we can now start replacing our C# code inside of our assemblies with C# code in other kinds of assemblies. So it's going to be a very easy task, as you will see. So we have many benefits, I would dare saying. Not only that we have a faster solution, native solution that works on AL language level, we also have a possibility to decouple our code. So it's not tightly bound, intermingled all together, assemblies with versions and everything. When you have an Azure function, you have seen that I've changed the same Azure function a couple of times. I didn't need to restart anything. I didn't need to stop. I didn't need to deploy anything new. I just changed URL. And sometimes, depending on how you write your application, you may not even need to do that. So it's all up to you. So Azure Functions are really a very good replacement for that part of .NET stack, which is not yet replaced by Microsoft. Mind you, Microsoft also wants to introduce more and more functionality in this AL language .NET replacement stack. But still, Azure Functions are going to be #1 way to replace those things which are not natively supported by AL language. So how do we replace .NET if we have some code that uses .NET? We have 2 possible situations. The first possible situation is that we have some code which uses what I like to call CAL.NET. It uses a bunch of .NET variables of this and that type, and then we write everything in AL, we don't have any external dependencies. Everything that we use is from .NET Framework Stack, native .NET Framework Stack, which means we can run it on any server without deploying anything to add-ins. If we use that, then we will have a little problem. So we will first have to do something with it. This is more complicated situation, at least for migrating to Azure Functions. The simpler situation is if we have everything already written in C#, and then we have an assembly which we are simply consuming from AL. So in AL we have 1 or maybe 2 or 3 variables which are of .NET type which reference that assembly, and then we are invoking it from there. So that will be a much simpler thing to replace. And let's see how we actually approach these two situations. The first situation is if we have CAL or CL.NET, if we want to replace it with Azure Functions. This is what we would have to do. First, we would have to start by translating this to C#, because eventually your function will be C#. And then when you have it in C#, you can start running it. But if you have it in in CAL.NET, it is worthless. So you will not be able to use all of those variable types anyway. So first step is create a new solution, put your C# code in there, translate your CL into C#, then build it, then deploy that, and then refactor your CAL to actually use the Azure function that you have created. Or actually, sorry, not Azure function. The first step is to actually refactor to use your assembly. So you need to get from CL.NET to real.NET so that you just replace individual calls with one .NET call. Good. Let's take a look at how we would approach that problem. So let's replace .NET, which is completely written in CL, with some Azure functions. So the first step is not going to involve Azure Functions at all. The first step will involve exclusively CAL and C#. So let's take a look at what I have here. I will go to Items, and then I will open this touring bicycle. And then I have a function called upload image. So this upload image is this code unit written in CAL, which has quite a lot of .NET. So this is completely written in CAL.NET. If you want, it has no external dependencies. I can just take this FOB, deploy it anywhere, it will run. So if you take a look at what kind of variable it's using, if I go here, you'll see that it has quite a number of things that it uses from .NET Stack. So when I click this upload image, it will invoke that code unit. It will ask me to select an image. I will select an image. This is a bicycle image, which is fairly big. And I do not want to have big images. I will first resize it, and then I will crop it to 300 by 300 pixels. So that's what my function does. So there it is, my touring bicycle. I can actually verify that it is resized and cropped by pasting this image in here. I can see that it's actually 300 by 300. So this AL code or CL code has done its job. But this is not good, because I cannot really turn that into Azure function that easily. My first step is to turn that into C#, and then try to have exactly the same functionality from CAL by invoking that C# that I have to deploy. So, of course, I will not do it step by step because there's a lot of code. I have prepared that project, so I will just go to my Visual Studio, and I will open. Just a second. I will open. Whoops! I have to stop or detach my debugger first. So I will open this TechDays 2017 solution. And here I have exactly the same. I have two classes, the helper class, which just handles the stream part of everything, which is, if you take a look at this, it's in essence the streaming part. And then I have this image manipulator, which does this resize and scale and crop and whatever needs to be done. So this is my AL just translated to C#. Then I have deployed that C#. I have changed my CL code, so it now looks like this. So everything I have from .NET is this. I have these three types. I have to retain at least some .NET in here, because otherwise I wouldn't be able to perform everything, but that's not going to be an obstacle, because I will handle it easily from my Azure function. So let's take a look at what happens if I invoke this other function. So it's exactly the same code, it's just my .NET now is executing, my C#. So when I click this import image C#, actually let me get rid of it first. So I will upload image from C#, the same image. It will be exactly the same result because it's the same code executing this time from C#, not from CAL. So that's the first step. You need to get your stuff completely in C#. And then what do you do then? What do you do when you have it in C#? Well, now the easy part comes. So once you have your functionality in C#, you actually take this same solution that you have just used from CAL. You simply add another project to that solution, which is of Azure function type. And then inside of that project, you reference your original C# assembly. And then you publish it. So that's all. And since you're using this dependency that you have just written for yourself, and since this is all C#, and since this is all just supported by .NET natively, and since Azure Functions do support .NET natively, it only takes those few steps. So let's actually do that now. So let me actually demonstrate how to now use this new solution that I have created to move it all to the cloud and enable me to use this functionality that I've completely had in CAL, how I can do that from AL language in extensions v2. So I will close this and I will simply right-click my solution, click Add New Project. I will select Azure Functions. I will simply call it Azure Manipulator and click OK. There I have it. When it completely builds, so I will know that when this dependencies warning sign goes off. So now it's completely built. I will right-click dependencies. I will click Add Reference. And I will simply select this project and then Image Manipulator. This is my C# project, the one that I've just used from CAL. So I reference it from here. Then I right-click my Image Manipulator, Azure Manipulator, and click Add New Item and select New Function. I will call it Scale and Crop, exactly as it was called earlier. I will specify that it's an HTTP trigger. I will specify that it has anonymous access rights, and I will click OK. So there it is, a function that does this hello world. So instead of this hello world, of course, I have to now put this streaming part of logic, which is simple. I have copied it in here. And I will just replace this body with code that I've prepared earlier. So there is no magic in here. There's just some streaming happening where I receive the stream from the request. Then I interpret or actually load that stream in an image, do a couple of image manipulation operations, and then save the stream back into the output stream. It complains a little bit because, of course, it doesn't see all the references. So I will have to fix that. I have to reference system.io. So I reference that first. Then this image manipulator is also not recognized, so I will just use TechDays 2017. And this image format is complaining, so I will just reference using system drawing.imaging. And that's it. So my function is ready. And I can now go and deploy that function. So I can try building just to see if everything works fine. If my Azure simulator worked, I could test it immediately from my machine, but since it's not working, I will not lose any time on that. So it builds nicely. I have no errors. I will just right-click this image manipulator and click Publish. Then I will select existing application. I will click Publish. I will again create a publishing profile. So let's just wait for a second until it refreshes. I will put it in my NAV TechDays 2017. And then I will select this application. I will click OK. It is preparing the profile. And when the profile is prepared, I will be able to click Publish. When I click Publish, my function will appear inside of my function application in Azure. And just by creating some AL code, I will be able to replace it. So let's actually do that AL code while the publishing profile is being prepared for me. So here I have another page extension, which is item card extension. Everything is ready, so I will just remove those comments. So what do I have here? I have an action which invokes this code unit image management. It invokes this upload image function. So image management is my AL code unit. In fact, this is nothing but AL translation of this CAL code unit. So it has those two elements. The first one is which handles this input dialog, and the second part is instead of this stream handling, which is now part of my Azure function, it actually just handles invocation of Azure. And this is the Azure invocation part. I simply convert my stream containing the image into a request. I actually stream it as application octet stream, which is just the way to serialize your byte array when sending it to a web service. Then I invoke my web service. I will simply replace this URL with whatever correct URL I will get from Azure, and it sends the request. My Azure response does image manipulation and gives it back to me. So let's take a look if this is ready. Yeah, I can click publish. And in a short while, there will be a new function available in my application that I will be able to invoke. Okay, I can go to my application. I can refresh the application. And I can see that I have this scale and crop. I just take the URL, copy the URL, and paste it in here. I don't need to add any parameters because this is being sent through the body rather than, through the headers and content rather than through the query string. So I will save this, I will run this, and it will add a new action to my image card. So I'm going into items. I will select this touring bicycle. Let me first remove this picture. And then here I have this invoke Azure action, which has just appeared. So I will invoke it from here. I will select choose, select the same image, click open, and now it's Azure handling it. And there we go. It's the same image. I can actually verify that if I copy the image address, that it is really an image of 300 by 300 pixels in size. Just to show you that this is not smoke and mirrors, I will go into pictures and open this one. This is fairly big, you know, it's certainly not 300 by 300, it's actually 2600 by 1607. So this is now my Azure function responding. It took me all 6 minutes to get it from CAL into an Azure invocation and having it actually do something fairly complex. So what else can we do? So far we have seen how easy it is to create functions. We have seen how easy it is to deploy functions. We have seen how easy it is to debug them. We have seen how easy it is to invoke them from AL language, how easy it is to actually turn previous CAL into new AL and having your Azure function up there in Azure. So what else can we do? Is there anything else we can automate? Oh, yes. So one thing that we can automate, which is absolutely worth your attention, and this is that demo that failed for me. I just couldn't make it work today. But I will try something because I have some theories why it couldn't work. So I will just test one theory here in front of you. You will humor me those 2 minutes that I attempt to do that. So what is this continuous development about? We have a possibility. Once you have your function developed in C# inside Visual Studio, that you simply take this solution from Visual Studio, put it into a repository, something like Git, for example, or something like TFS or whatever, and forget about Azure Functions completely. Because everything is going to be completely managed for you by the Azure stack. So let's take a look at different providers which allow us to store the source code of our Azure function. So we can use Bitbucket, Dropbox, Git, installed locally on your machine. You can use GitHub, you can use Visual Studio Team Services, or you can use OneDrive. So all of these are options which allow you to store your source code and then connect your Azure application to that repository, and then keep your application up to date. It will automatically detect when there are any changes, and it will automatically refresh your application. So, without me talking too much about that, let's take a look at how we can actually automate our deployment using Git. If you're not using Git yet, I hope you will start using it today, because Git absolutely rocks. So, what I will do here is I will start with a new solution. So I will just start File, New Project. And here I will create a new Azure Function project, and I will call it Git Deploy. And I will just click OK. Inside of this Git Deploy, I will simply add a new function, which is called test me, and it will be HTTP trigger, and it will be anonymous, and I will click OK. So that's all I need. I will not publish it to my Azure. I will instead connect it to my Git. So I will right click, and I will click, solution, right click, add solution to source control. Okay. Here, I will click Publish to GitHub. I will use publish. What did I do? No, I apologize. Let me just, this will be quicker, trust me, so I will just create it again. So, function app called git deploy to, and a function in that app which is called test me, and this is HTTP anonymous, okay. And then I'm going to add this to source control, and then publish to GitHub. So I will just click publish on this. Okay, so I will not mess up again. So now we'll go to Git. There will be a new repository for me on my GitHub. I simply need to commit all the changes. So I will just call initial. In just a second, let me take a look at, everything is actually already there. It is, let me just go to home and let me click to sync. So sync. Let's take a look at GitHub. So inside of my GitHub, if I go to my repositories, I will see this git deploy to. It has my solution, it has my code, and then I will go to Azure, and I will click on this application. And then I will go to Overview, and then Application Settings. I apologize. I will go to Platform Features, and then Deployment Options. From here, I will click Setup, and then I will click Choose Source. I will choose GitHub. If you have not configured GitHub with your Azure subscription, at this stage, GitHub would like you to authenticate. Since I did that already, it doesn't ask me to do that. So I can simply choose which project to use. This is this git deploy to. That other one doesn't work for whatever reason. And everything else is fine, so we'll just click OK. So if I'm lucky, and I don't know why it didn't work earlier, what will happen now is my Azure Function application will connect to Git. It will fetch the changes from there, and then it will build my application inside of my Azure application on the server. And when that happens, I will actually have let me take a look at what's going on in here. Yeah, So it's adding project files now. It says that it's building. So it will take a little while, so maybe 2 minutes until it builds. What is the idea of this continuous deployment? The idea is that you can actually start working in your development environment the way that you would normally work with some kind of source control in the background. And of course, you would not be working in your master branch as I'm working in it right now. You would probably select one specific branch that you want to build from. If you remember, when I was configuring this application to connect to GitHub, it asked me which branch I want to use. I've just selected master because I have master. But you can easily say I have Azure deploy branch. And then when you have this Azure deploy branch, it would always pull stuff that is present in that branch when that branch is committed or actually synced with GitHub. So once you have all that configured, GitHub will notify Azure that there is a change in this repository. And then when there is a change, Azure will simply fetch all the changes. It will locally rebuild your application. And when your application rebuilds, if there are no errors in that application, it simply exposes all of the Azure functions which are present in that application inside of your Azure Function app. And you can see it online, and you can then access that from Visual Studio Code or from NAV or from anywhere else. So this is the idea. Then, as you're developing, you don't need to publish, you don't need to do anything. You're simply working as you would normally work. And then once you're happy, you simply merge your changes into the target branch. You push your changes to GitHub, and GitHub and Azure do everything else for you. So it is still building, as I can see, but in a short while it will be completed. And when it's completed, I'm pretty sure I will be able to see it in here. So to not just stand in front of you and chit-chat meaninglessly, let me actually just continue with everything else, and then I will immediately come back to that at the next demo point. Let's first talk a little bit about performance of Azure Functions, and then we'll go back to this Git. How well do those functions actually perform? So that's a question you may reasonably ask. Well, what you think is happening is probably what is happening. They are not the fastest thing in the world. And why are they not the fastest thing in the world? Because they are some Azure service sitting out there, possibly far away from where your server is, where NST is, from where you're invoking them. And then there will be some network latency. And then, of course, every time you invoke an Azure function, it needs to provision your container, it needs to start it up. Sometimes it is fast, sometimes it may take a while. But it's not that bad. You know, I've now explained a lot of things that happen, but it certainly takes Azure far less time to do all that than it takes me to explain what happens. So we'll quickly see exactly how fast or how slow that is. So let me just demonstrate the performance of Azure Functions. So let's see if it's actually slow or fast. It's still building this, so I'll let it build, and I will come back to this demo a little bit later. Let's take a look at my functions. I will just open another instance of Azure Portal. I will click my function apps. And then I will click this function app that I have prepared earlier. And when that function app refreshes, it will show me all the functions inside of there, and then I will be able to see a couple of them to see how fast they perform. So here I have some performance test, C#. What does it do? It simply adds 5 million entries into a list. Good. I will run that. And then I will let it execute. So for 5 million requests, okay, it's now processed the request. It says that it needed 7 seconds, 7,400 milliseconds. I will run it again because it had to spin up the first time. So let's see what happens when I invoke it second time. It will tell me that it took 6.2 seconds. So that's not that bad for 5 million operations. Okay, but this doesn't really tell us anything. Let's see what it means to invoke an Azure function, which sits somewhere out there. And let's see how well it performs then. It's easy for me here to see that it took 6.2 seconds to run a function from the environment where it is actually hosted. Let's see what happens when I invoke it from my NAV machine, which is who knows where, as compared to my Azure service where it's physically stored. So I have prepared some demos in here in AL. So I have this Azure Functions code unit where I have this invoke demo, which I've used earlier, and I have this measure performance. So what does this measure performance do? It simply invokes a number of functions which are exactly the same copy of exactly the same thing, just hosted in 6 different locations. Let's take a look at what those locations are. So I have these functions called, function apps called Test Tech Days AU, this is Australia. I will expand that one. Then I have it in Ireland and in Netherlands. And then I have it in Netherlands, but in the same resource group and on the same storage account as my virtual machine is. So let's see if that has any effect on the actual performance. Then I have one in Singapore and one in central US. And what does the function do? The function is actually my very simple hello world. So it's that function that is created by Azure itself as a demo. So this function is actually fairly lightweight. So it doesn't, whatever time we measure will be actually the latency between my server, my NAV server, and Azure Function endpoint. And it will be the time it needs to actually spin up this container in which Azure Function runs. So let's take a look what happens if I rebuild this and invoke measure performance. I will do 2 runs. Both of these 2 runs will be actually not. Let me just show what exactly I do inside of this. I actually invoke it 10 times. Each of them is invoked 10 times, not just once. Because one invocation would not give you exact number. It's just there are a lot of influencing factors. So 10 times will give you a number that you can divide by 10 and then get some nice approximation of what is going on. So I will invoke this same function 10 times, and it's going just to be invoked on 6 different places in the world. So I will run this. It will take roughly half a minute to execute, after which I will see the results. I will see how much time it took for me to execute all that. And what? Let me close these that I don't need anymore. And let's just make sure that everything is fine. Okay, if you would allow me just to go a little step back and take a look at this one. GitHub says that it has deployed my function to Azure. So I will just go to Azure Apps, and click OK here, and then I will take a look at my NAV TechDays 2017, and I will take a look at functions in there. It's refreshing, and I can see that I have this test me function. So this test me function is now going to execute this code that we have seen in here. So it will say hello, whatever. Okay, I will do another change and then let GitHub do some more stuff while I'm demonstrating performance. So this is going to be adding, actually changing this hello. I will just put hi there and then how are you? Just so that we can see that there is some difference. So I will not publish that. I will simply go to my changes. I will commit this as update into my master branch, and then I will sync, and then I will sync. So it's now going to be pushed to GitHub. When it's pushed to GitHub, I can check my Azure function. I can check my, just a second until it refreshes. I can click this deployment options. And then from here, I will see that it detects that GitHub is updated. So it's updated, it's now refreshing, and in a short while, it will actually put everything back. At the same time, while GitHub is busy with deploying this function, I'm going to check what's wrong with this piece of code. So let me actually verify that all of these URLs are actually working, because I suspect that I managed to break one of those earlier today. So let me try to see. This one should work fine. And this one is what I suspect could be broken because I was playing with that and I shouldn't have. So oh yeah, this one will not work because the, let me just select this NAV TechDays 20, sorry, this one. I think this URL is not correct. So I will just, inside of this test TechDays application, open this function and recopy the URL and repaste it into NAV because I think it's not the same. It's the app key that has changed. So I will just, well, it seems to work. I don't know why. So we'll just replace this just in case. So let's take a look. I will rebuild this again, and then I will actually set a breakpoint in here to see if there is something wrong. So I'll press F9, and then I will just run it in a debugger to see if something is not being invoked as it should. So I click Invoke Asier. It seems that it's not invoking my so I will stop it because something else is happening. Let me just check my auto processor extension. Ah, yeah, this is the problem. I'm not even invoking my code unit. So code unit is called Azure Functions. So I will redeploy, and this should now work. So when I click Azure Functions, okay, I did not run it with a debugger, but my functions are now happily executing, and I will let it run. I will just stay for a little just to see that that error doesn't pop up. It seems to not pop up. Let me take a look at what's going on with my Azure deployment from Git. So I will select this application again. Is Git still busy? So it says that it has completed this update. So I will not do anything right now because I have a demo running. So I will just let this execute. Before it completes, I will just let you know this. There is going to be increasing latency between those endpoints. So Amsterdam, which is right next door, is going to be very fast. It will be just a couple of seconds of total invocation time, which would roughly put execution time per function invocation at 300 milliseconds. So one function to execute actually will take roughly 300 milliseconds. And it is mostly because, oops, what is this? This is now internet issues. Well, I hope internet comes back. And yeah, it's back. And results are back. So if you cannot see that, it actually says that Netherlands is 3 seconds and 832 milliseconds. Netherlands' same storage is 3 seconds and 323 milliseconds. So I didn't gain much by putting everything in the same storage account. So currently my virtual machine and my Azure Function application with everything are stored in the same storage account. It has only gained me roughly half a second, or roughly half a second per 10 invocations. Then Ireland is 9 seconds, nearly 10 seconds, Central US 14 seconds, Singapore 21, Australia 15. So this is latency. And this is to tell you that when you're using Azure Functions, you actually have to put them as close as possible. Latency is going to be your biggest enemy. Performance is good, it's just that latency is bad, and you have to somehow handle that. So it's certainly not a good thing that you have to wait for roughly 2 seconds when you're invoking it in Singapore, for example. So what did I do? I managed to break everything with this magnifier, so we'll just get it out, and I will move on. So Actually, I would like to show other demos, and then in the end we can go back to this GitHub deployed, but trust me, it will show that message. So let's take a look at this thing. Which language should you actually use? When it comes to languages, developers really love crusading. Like, my language is better, C# is better than JavaScript, F# is better than C#, Python is better than all of you and stuff. So which language is actually the best language to write Azure Functions in? The choice should be yours. There is no rule. All features are supported in all of these languages, and Microsoft is adding more and more language support to Azure Functions. You can combine them. You can have applications which combine multiple languages. But do they really perform the same? So I'm kind of a JavaScript guy. I absolutely love JavaScript. And people tell me JavaScript is not a real language. It is interpreted. It is slow. You should not be using it. You should use TypeScript, whatever. That's just nonsense. TypeScript is JavaScript. It's not going to run faster than JavaScript. And what people say, like C# is going to be much better than JavaScript, I will just prove you wrong, or actually prove anybody wrong who says that C# is a better choice for Azure Functions, or for anything for that matter. Actually, let me compare the performance of the same stuff happening under different languages. So I will just go into my Azure platform, and I will take a look at my function apps, and then I will expand this app which has the same function running under 3 different languages. I will compare C# to JavaScript to Python. So here I have, C#. Should I have F#, but I don't care. C# is doing this, so it's inserting 5 million entries in a list, and we have seen it already. So I will click it, and then it will show me that it performs those 5 million operations in, what was it, 6 seconds or something like that? So, wow, 11 seconds. But that's because it had to spin up the container. So run it again, and it will be less. So, okay, 7 seconds. I will click JavaScript. Let's take a look at how well does Node.js compare to common language runtime. So I'll click run. It does exactly the same thing, so it creates an array and then pushes 5 million times the string, actually the number converted to string. So it's exactly the same operations, just written differently. So here I have it in first time it is 10 seconds, and then second time and third time it will be less. So first time it had to spin up everything. So it's done in 2.8 seconds. Twice as fast as C#. Second time again, and it's going to be again roughly twice as fast. Okay, while it's executing, I can actually click Python. So, okay, well, if you click it enough, often enough, it will be consistently faster. So C# cannot hope to get to those 2.5 seconds. And Python, let's take a look at Python. It will be actually slower than C#. I don't know. I actually don't know much about Python at all. I know that people love it, but it doesn't really. If you're comparing performance, it's not such a performance beast, obviously. So the point of this exercise here is not to tell you like you should all write JavaScript for Node.js. JavaScript is compiled and it runs pretty fast. It's very solid language. It's to say that you should choose language that you're comfortable with. You will not have any problems using any of the languages available. All of them have the same features. Probably the language choice will be about dependencies that you can use. Okay, so Python did this in 2.6 seconds. Is it possible? Whatever. It is, yeah. So it's okay. It will show some number. We can come back to that later. How do we secure Azure Functions? There are a number of ways to secure them. So far, I've been invoking all of them nearly anonymously. So all of the functions I created were anonymous functions, so anybody who has the URL could access them. So how do you secure them? There are 2 ways. First, you can secure them using access tokens. And those access tokens are, in fact, just that cryptic string that you put either in the query string or in a header, in authentication header. And then whoever passes the correct string, that string will be evaluated and accepted or rejected by the application. We call this security by obscurity, because it's how difficult it is for anybody to obtain that access key. So when you talk to security experts and you ask them, does security by obscurity really work? These are roughly the answers that you can expect. What is probably the better way to implement authentication is to use authentication protocol. However, there is a big problem with OAuth. OAuth is user-level protocol. So if you want to implement OAuth, you actually need users to authenticate, not the application to authenticate. And then when we come back to this nonsense of security by obscurity, it is actually fairly good as long as you are having service-to-service communication. Your service is not exposed. It is using HTTPS. So it's going to be as secure as HTTPS. And if only your service knows this secret and you don't share it, it will not be such a big problem. So the point is, you should actually not spend too much time configuring some more complicated security than simply adding those authentication tokens. So I will simply show you how to secure access using authentication tokens. I will not be showing how to do full OAuth because I honestly don't know how well it would perform in a service-to-service communication scenario. Here we have CEL invoking Azure Functions somewhere out there. Why would you want to authenticate a user for that kind of authentication? This is just a service thing happening, not a user function happening. So here I'm in my Azure function. If I click this URL, I can see that it doesn't have any authentication because it is anonymously authenticated. If I click on Manage, I will be able to specify a new, sorry, is it here or just a second? Here, sorry, integrate, not in authentication. I will choose authentication level and I will specify is it admin or function or anonymous. It has been anonymous. If I click function, it will allow me to save and then it will allow me to add keys. So let me just take a look at, why is it so slow? I'm running out of time. Yeah, something is bad with this today and I don't have a clue. Anyway, let me just skip over that. You would have to create a key. That key would appear in your query string and you will be able to pass it. That's it. I'm sorry, time is running up and Azure is really slow and I cannot make it faster. That's all. So that's all I had to present. Now it's time for questions. We have 3 minutes and 28 seconds. And you know the drill. It's shirts for questions, but questions have to be smart. So, question over there. You're next.
Yeah. Hi.
Hi.
So, in general, you have shown that Visual Studio is the preferred environment to develop.
I didn't catch that.
Visual Studio is the environment, but
yeah.
Which edition you
2017. This was Community. So I use Community edition here. So you don't need to have anything higher than Community.
And is it working with a lower version also with Express, for example? Because sometimes you're not allowed to use Community
I don't honestly know. I know that it works with 2015. Just you need to install Azure Tools, which you need to download separately. And for Visual Studio 2017, you don't need to download them separately. They are embedded in the install process. Okay. I don't know about Express.
Because Community has some limitations.
Yeah, but you need 2015 at least. Yeah.
Okay.
Okay. Second, yeah.
As you said, we use .NET interoperability in order to access web services and such things and so on, but sometimes we use it also to connect to some other applications or other databases that are not in the cloud, they're locally. How we can do this?
Well, you would have to use probably Service Bus or something different to access your local resources. This is possible, it would just be more complicated.
But we have to publish this to have...
Well, if you have that situation that Azure cannot possibly talk to your local resource, then you would have to host everything locally. So you would just have to develop a service application locally which exposes HTTP endpoints that you invoke from AL. It would be just like developing any service application. It can be WCF, for example, and that's it. Yeah. There was a question over there.
Regarding service-to-server communication, is it also possible to do whitelisting on Azure Functions, so to say, only those IP originating calls are allowed from a certain IP address?
Well, that's something that goes to infrastructure of Azure. I'm not an expert in infrastructure on Azure, so I cannot tell you exactly that this is impossible or not possible. I assume it is possible because you can normally configure Azure firewalls, and I'm pretty sure you can configure it for this thing too. It's just that I cannot tell you today this is how to do that. So I'm pretty sure you can, I just don't know how exactly. So,
would you consider it to be another way to improve security?
Sorry, I didn't catch that.
Can be used to improve security by?
How can we use what to improve security?
To prevent illegal access to your services, to your functions.
I'm not sure I understand the question. I apologize.
It's okay.
Can you try to rephrase?
If you whitelist who is allowed to use the Azure functions,
yes,
you can use that as a means of preventing illegal access or unauthorized access or unwanted access.
Well, I don't know answer to that. I'm sorry. Yeah. Yeah, T-shirts. I forgot T-shirts. Yeah. There were 3 questions. You asked the question. You asked the question. I asked the questions. Yeah. There is a question over there. Yeah. Please try to. I cannot catch half of what you guys are saying, so I just have to assume what the question is about. So try to.
Do you think Microsoft could be publishing some of the Azure functions for NAV community to use?
I don't know, but I assume yes. So.
Do you think how likely is it?
Maybe we should ask them. So.
Okay.
I don't know. So I would love to see that, but I cannot tell you how likely that is.
Yeah.
Yeah, what I would like to see, for example, is NAV exposing some hooks for Azure Functions to hook into. That would be amazing, but I don't know. They say that's a possibility, but yeah, let's keep fingers crossed. That would be lovely. Yeah.
Okay, so you have shown it always with your Azure account, with your small Azure machine, but in real life, it's coding for a customer of you or for a hand of customers.
Mm-hmm.
And if you're deploying your Azure functions, you should usually, I guess, deploy them to the customer's Azure account, right?
Not necessarily. So this is an API, which is public API. It can be your API. It can be part of your service offering. So if you're talking Dynamics 365, it can be part of your service stack. You do not need to have a customer's account to host them. So everybody who is your customer will be able to invoke your stack. That's the point.
So I should just make a contract with my customer. They pay for use my API.
You necessarily don't need to do that because they are using your service. So you're paying for Azure, it's your Azure, and your customer is your customer's database is calling that instance.
Yeah.
I don't know why you would have to have any kind of contract. Why customers would even have to know about that?
Yeah,
I don't think that it's even necessary. So it's just a part of their application. So, yeah.
You know, with Germany and Azure in Germany, they are cloud.
And pricing.
Well, tell them that their bank account is in the cloud and their money is in the cloud. So. Any other questions? Okay, let me try to not kill you when I throw this over there. Oops. Everybody live over there?
Yeah.
Okay.
Everything is fine. Just a short question. Can we call these Azure functions from CL?
Yes, you can. So you will just have to use .NET interop, the guy you are trying to replace.
Mm-hmm.
So you will just have to use exactly the same classes. So you have this HTTP client class, which I use every single time. This HTTP client is system.net.http.http client. All of those types, HTTP client, HTTP request message, HTTP response message, blah, blah, they all come from this system.net.http. So you simply take your AL code, convert it to CL by changing the references of actually the declarations of those variables. What was HTTP client becomes .NET of subtype system.net.http.http client, and there you go. So
okay, thanks.
easy. Sorry? Oh yeah, you can use the code unit which is built by Microsoft for that purpose, for invoking web services, yeah.
I have a really important question. Can I get such a cool T-shirt?
I'm out of shirts, honestly, so they're not left. So
Then I will take this with me. Thank you.
I don't care.
I care.
It's not mine. Any other question? Okay, over there, first row. So, let me try to kill somebody from Microsoft.
Hello.
Hello.
The example the other guy there mentioned before, where you deploy your API for your function for the customer, and the customer maybe moves away to another partner. Do you have any views or access to check if the customer still uses your function?
Well, you have. So you can always go to the function, and if my Azure is alive, and I hope it is at this point, yeah, you can click this monitor. And here in this monitor, you will be able to see that.
We have to switch.
Yeah, anyway. You click the function and then click monitor. There is monitor node underneath the function name. When you click that, it shows you all of the invocations, and you can see if they are being invoked. So that, yeah. So you can see all of the invocations. You can see what was sent and
From where?
Well, I'm pretty sure you can do that not from here. You have also one thing called kudu. So you would click the application itself, and then I don't know how much time we can actually stay here. I will click on platform features, and then I will click on, where is it here? Advanced tools, kudu. This is a kudu tool that Microsoft has made a part of the Azure Functions stack. And from here, you would go to Tools and then Web Job Dashboard. And then from Web Job Dashboard, you will see nothing, but then you would click Functions. When it wakes up, Azure is mighty slow on here. I don't know why. It should be a decent VM and everything, and I don't know why it takes so much time. So click Functions, and then in here, you will see all of invocations, and here you can see a lot of information about that invocation. So yeah, I cannot see from here where from the call comes, but I'm pretty sure that that is logged somewhere, and this has API to invoke, so you could probably use that API to reach that. Yeah.
Customers to use your functions?
Yeah, there is. There is a way, because you control the keys. You control those access keys, and when you have access keys, you can assign them per customer. Every function can have a number of access keys active at the same time, and then you can switch them on and off.
Okay.
So you can easily say, like, okay, this access key is not valid anymore, so nobody can use it.
Okay.
So that's one way. Yeah.
I think we need to wrap up.
Okay. Thank you very much for attending, and see you